Okay, so our next part we're going to talk about in our unit review is problem number 4. 1 through 3 is the previous video. And so we're going to talk about how to give me the equation of the axis of symmetry again. There is another video somewhere in those stashes of video. I think it's under quadratic topics or something like that, where you can go and look and see me do another one of these. But anyway, so we're just trying to state the equation of the axis of symmetry and find the coordinates of the vertex and graph. Alright, so finding the axis of symmetry is actually very easy, especially if you're given to you in vertex form, because basically all you write is x, if I can get it to work, x equals 3. Okay, it's because the x coordinate is whatever makes that equal to 0. You can think of it as whatever the x coordinate is of the vertex, that's also equal to the equation of the line. And basically we have the vertex, which is basically 3, comma, and then this number right here is just brought down, because remember that the equation is written for y. So basically we have to do the opposite for x, and then we take the same as y. And I'm going to start this. Next thing we have to do is graph this, and it has to be accurate. So if you see sketch on the test, use this to sketch it. If it says graph, you have to actually put 5 points. So we're looking for 5 points. That's gonna that we're gonna graph. One of which is sitting right here, and we're gonna use that when we look up our table. So let's get this calculator fired up. Okay, so we have the graph up here on the right. I mean the equation y equals. All you need to, if I want to graph, I'm gonna go to my table. Second, actually, let's go look at what this thing's setting up. That's fine. All right, go to my table, and remember that my excuse me, my vertex is 3, 1. So here's 3, 1. Wait, hold on. What do I have typed in correctly here? Should have 3, 1. So let me go check this real quick. Hold on a second. Alright, I just realized that this needs to be I have 2, and this needs to be a 3. So that should fix it. Alright, so I go to my table, and sure enough, there's my 3, 1. Okay, and I'm going to pick points on either side of 3, 1. Okay, so here's 3, 1. Now, notice I don't have to pick the ones directly after it because it makes them decimals, and I want to graph decimals. So if I want to I'll use a table down here. Basically, I'm going to graph, let's see, I'm going to graph negative 1, 9, I think. Let's see, there's 3, 1. Here's 1, 3. 1, 3. I'm going to do negative 1, 9. I'm using my, let's use this. 9. Wow. Alright, let's see, and I'm going to use, that's going one direction. Remember, now you got to go the other direction. Okay, so I'm going to pick, so I've got 3, 1 in here. So I've got to pick 2 more. So I'm going to pick 5, 5, 3, 5, 3, and I'm going to pick 7, 9, looks like. Okay, so all of those are, and then my 3, 1 obviously gets squeezed in right there. Alright, so I graph all these things. So let's see, let me change color. Let's do green. Okay, alright, so I'm going to do 1, 3, 1, 3. This is always such fun with this graphing tablet. Okay, 1, 3 is here. This is not going to be fun. Alright, 1, 3. Then I've got, wait, why did I produce 1? Oh yeah, 1, 3, then 5. 1, 2, 3, 4, 5, 3. Oh, this is going to be a mighty pain. Alright, plus I can't see them very well, so let's use something dark. Alright, and then I've got negative 1, 9. 6, 7, 8, 9. Wow, this is a pain. Anyway, you get the idea. And then I'm going to do 7, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that's going to come up here and move everything. I'm not sure why it keeps wanting to do that, but let's move that up here. All right, and then obviously my three ones right here. 3, 1. Ay, ay, ay. Well, you get the idea. All right, so I'm just struggling with technology. I'm not sure why my graphic has to keep moving because it's kind of annoying. Okay, so the idea is you'll get 3 points going in this direction, and then we'll get another in this direction, and you have a vertex. Trying, but I'm not successful. But anyway, it should, again, if you graph your points correctly, you'll get all 5 points, then you'll get some nice, beautiful graph. Hopefully a lot better than what I did here. So let's just keep going because I'm just going to keep trying with this one. Okay, write in vertex form. Okay, so we've practiced this before. We need the vertex in order to write in vertex form. So we're going to use x equals minus b over 2a. And remember that this is the a, this is the b, and this is the c. And we're not using c right now, but that's what we would do. So minus, now b is negative 24. Why is this being such a pain today? And then 2 times a. Okay, so that's going to give me positive 24 over 4, which is a 6. Okay, then I'm going to go look up 6 in my graphing calculator, and it looks like my graphing calculator is conked out, so hold on a second. Okay, so what we're going to do is we're going to go put this in the calculator. 2x squared minus 24x plus 7. Okay, and then we're going to go to our table, and we're going to look up the number 6. 6 comma negative 65, it looks like. All right, so let me put this down here. If 6, so 6 negative 65. So our equation is going to be y equals, you take the a that's in the original problem and it becomes the front of the new problem, and then remember that this is written for y, so x is the opposite, square to make it quadratic, and then whatever the y is goes right here, and you're done. State the minimum value of the range, and that's easy. All you're going to do is take your y value, which in this case is negative 65. Since this thing is pointing up, that means all the y values are greater than equal to negative 65, because all the values are bigger than that in the graph. All right. Given this equation, does f of x, remember you can think y here, have a minimum or a maximum? How can you tell? All right, it has a maximum, and the reason why you can tell is because this thing, because of the negative in front of it, will cause it to go downhill, or upside down, open downward, which means that this is a high point. If this is the high point, then this would be the max, considered the max. Okay, and that's it for these questions. How much time we're at? 9 minutes? Okay, let's do another. Okay, so actually I'll come back to that in a different video.